Hi, Year 10. I'm just going to go over the probability sheet that I've left you with whoever's teaching you this time. Let's have a look at the first page. What I'd like you to do is follow through on your booklet so that you are watching the same thing that you can see on the screen. Okay, we've got some basic definitions. We did this really quickly last lesson when we were looking at the Melbourne Cup, but let's go over them again. So for probability, you have terms like an event, and a situation which could have different outcomes. So anything where you are testing something can be an event. The Melbourne Cup, throwing a coin, rolling a dice, any games that you play, anything like that is going to be an event. An outcome is any possible part of that event that you're looking for. So if the event's tossing a coin, the outcome could be a head or a tail. If your event is throwing the dice, rolling a dice, your outcomes could be rolling a 1, a 2, a 3, a 4, a 5, or a 6. Some people get a bit confused with outcome and sample space. So an outcome is a possible result, but your sample space is a combination of all the different outcomes that can happen. So if you see here, we've got rolling a dice. All your outcomes go from 1, 2, 3, 4, 5, 6. And notice they've got those little funny curly brackets. Those are what we use when we're listing our sample space. As you can see here, sample space tossing a coin, head or tail, and you can see they've got those little curly brackets again. Now a random event, as we talked, is just about having outcomes that are equally likely. So long as you haven't got a fake die that's got a bit of a weight in it, then rolling the dice is a random event. Tossing a coin is a random event. The Melbourne Cup is not a random event. Okay, so the next term is relative frequency. It's really not as much drag as what you think it is. A relative frequency, or experimental frequency, is the number of times the outcome occurs over the total number of trials. So if you, well, let's have a look at this one. A bag is full of 10 red, 10 blue, and 10 green stones. So how many is that altogether? 10 plus 10 plus 10, 30 stones. Let's say 12 stones are drawn from the bag at random in this order. You've got red, green, green, blue, green, green, blue, blue, red, 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 green. You get the idea. So the relative frequency of the red stones, it's only 12 are drawn out, is 4. Okay, 1, 2, 3, 4 out of 12. Whenever you do these, you always try to simplify your fraction as well. Make it simple. So find biggest number that goes into both these and divide by that highest common factor. The relative frequency of blue stones. Okay, count how many blue we've got. 1, 2, 3. So it's going to be 3 out of 12. The relative frequency of green stones. Okay, we've got 1, 2, 3, 4, 5 green stones is 5 out of 12. So not hard. Your relative frequency is how many you pull out of a certain outcome over how many you've got. This next example just shows you what happens, only this time you've got 14 stones. And as you can see, it's the same thing. So how many you pulled out of that colour, of red, over a total of 14, and then simplify your fraction. As you can see, we have slightly different results, okay? And that's because we're doing our experiment. We're not worried about what would happen normally. Alright guys, your turn. So if you turn to this page, can you have a go at answering these questions? I'll guide you through this one. So a coin is tossed once. What is the sample space? So remember, you're tossing a coin. You can either get a head or a tail. So that means your sample space is going to be one of those curly brackets, head, comma, tail, and a curly bracket. Tell us why this is a random event. If you're not sure, go back to our definition of random events and use those words. Following those examples, have a go at doing the rest of these questions. Alright, thanks, Year 10.